Hello and welcome to Video Podcast 12.6. The topic of this vodcast is types of precipitation. Before we talk about the types of precipitation, we should probably understand the mechanism by which precipitation forms. There are two explanations for the formation of precipitation. The first is the Bergeron process, and this process is especially applicable in the mid-latitudes and high latitudes. Even on a very warm day, we might not realize that at the very top of a cloud it can be below freezing. The Bergeron process basically says that the temperature in the cloud is supercooled, and tiny ice crystals will collect and accumulate water vapor. As the little ice crystals collect more and more water vapor, they will become large snowflakes, and when they get large enough, they'll begin to fall towards Earth's surface. The other process I'd like to overview is the collision coalescence process, and this process is especially relevant in the tropics and in warmer regions. The collision coalescence process occurs when large cloud droplets, which we call giants, collide and join together with smaller droplets to form raindrops. This process occurs in warmer clouds, where the temperatures are above freezing. A concept that's very important to understanding the collision coalescence process is that large cloud droplets will fall more rapidly than smaller droplets, and when a droplet gets heavy enough, it'll start to fall towards the surface. In picture A, we see a large cloud droplet, and on all sides it's surrounded by typical cloud droplets, which are much smaller. In picture B, our large cloud droplet has collided with some other droplets and grown in size. That raindrop growth continues in picture C, where the diameter of our large raindrop is now 4 millimeters, but you can see the development of a depression at the bottom of the raindrop. And as shown in picture D, when the diameter exceeds 5 millimeters for the raindrop, there's an explosive breakup of the raindrop. But we now see the formation of multiple cloud droplets, each of which will now go through that exact same process. I'd like to now overview the types of precipitation. The first two types that we'll talk about are rain and drizzle. There's a very subtle difference between rain and drizzle, and it's important that you know it. Rain droplets will have a diameter of at least 0.5 millimeters, whereas drizzle droplets will have a diameter of less than 0.5 millimeters. Drizzle is precipitation from stratus clouds that consist of very tiny droplets. As you may remember from our clouds vodcast, nimbostratus clouds don't produce very heavy rainfall, but they are notorious for producing a slow, steady drizzle that can be long-lasting. I'd like to take a look at the picture shown on this slide, but we're only going to focus on the left-hand portion of this picture for now. High up in the sky, we have a cloud that's occupying a region that's below freezing. Now, as stated in the Bergeron process, eventually our snow will start to fall towards Earth's surface when it gets heavy enough. But once the snow crosses the freezing point line, which you see indicated on the screen, the snowflake will melt and form raindrops. Now let's turn our attention to snow. Snow is ice crystals, or aggregates of ice crystals, and snow is typically produced by sublimation of water vapor. And just as a reminder, sublimation is the phase change in which water vapor is converted straight into a solid. And I'm sure you're already aware of this, but snowflake size, shape, and concentration can vary. The key factor that affects the size, shape, and concentration of snowflakes is the temperature at which the snow forms. Now let's turn our attention to the far right side of the image shown on this slide. Snow originates in a cloud that is well above the freezing line in our atmosphere. And as that snowflake continues to grow and grow inside of that cloud, it'll eventually reach a point when it's heavy enough to start to fall towards Earth's surface. As long as that snowflake's descent occurs entirely through regions where the temperature is less than 32 degrees Fahrenheit, it will reach the surface as snow. Now let's turn our attention to two types of precipitation that can occur during the winter months in the mid-latitude regions where we live. The first type of precipitation I'd like to overview is sleet. Sleet is lumpy ice particles that form while raindrops freeze while falling through a layer of sub-freezing air. Just as before, sleet's journey to the ground starts when a snowflake starts falling from a cloud in a sub-freezing region of our atmosphere. But something very interesting happens in this image. That snowflake will eventually cross the sub-freezing temperature line, and it will briefly encounter some air where the temperature is above freezing. In that region, the snowflakes will melt and form raindrops. Now, as those raindrops continue to fall through the atmosphere, they might run across more cold air. In fact, the cold air that you see at the bottom of this image is currently involved in frontal wedging. But anyway, as the raindrops reach that cold air region, the raindrops will become supercooled. And when we use the term supercooled, we basically mean that the raindrop's temperature can be below freezing, but the drop remains in liquid form. Now, if that supercooled raindrop falls through a very thick portion of cold air, it can freeze prior to reaching ground level, And when that happens, we have ice pellets known as sleet. I'll now discuss glaze, which is more commonly known as freezing rain, and it's important to note the very subtle difference between freezing rain and sleet. First and foremost, freezing rain occurs when supercooled rain droplets impact a solid, causing freezing. And it's important to note that those supercooled rain droplets will freeze immediately upon impact. And when they do so, they basically make sheets of ice, which can make driving extremely hazardous. Let's take a look at the picture shown on this slide and focus on the second path from the left. I'm not going to bore you by re-explaining the exact same mechanism, but what's important to note here is that the snowflake will encounter a region of warm air where it will melt and form raindrops, but those raindrops will fall through a very thick, warm portion of our atmosphere. Now eventually, not much higher than Earth's surface, the rain droplets will encounter a very shallow region of freezing air, and when those droplets hit that region, they will become supercooled. And that's the key here, because when raindrops are supercooled, they will freeze upon impact, forming freezing rain. But in summary, this is a very important picture because it essentially outlines 4 very common forms of precipitation. And I think it does a really good job of explaining the mechanism by which those forms of precipitation reach Earth's surface. Our last consideration in this video podcast is hail. Hailstones are nearly spherical ice pellets having concentric layers, formed from successive freezing layers of water. Now, hailstones' diameters can range from 1 to 5 centimeters, and some pieces of hail can get as large as softballs or bigger. In order for hail formation to occur, we typically have to have a pretty strong thunderstorm that has violent updrafts. The cloud type capable of producing these very violent updrafts needed for hail formation are cumulonimbus clouds. Now, to understand the hail formation mechanism, I'd like to call your attention to the picture shown in the middle of this slide. Let's start off by noticing where the freezing level line is, going horizontally across this image. You see coming from the bottom right very strong warm updrafts, and those updrafts will carry huge quantities of water droplets higher up into the anvil head portion of the cumulonimbus cloud. Once the updraft pushes those water particles above the freezing line, you can form an ice nucleus, which we often call an embryo. Now, as that ice nucleus gets shoved up into the cold regions of the cloud, it can collect supercooled water, and as it does so, it can start to gather layers of concentric shells. Now, the hailstone could start to fall back towards Earth's surface and then get shoved back up into the cloud by yet another violent updraft. And if that hailstone is getting pushed around in that cloud enough, it can form layer upon layer upon layer of ice shells. Now, depending on the strength of those updrafts, at some point the pellet will fall when it becomes too heavy. So in a sense, the size of the hailstones that fall is a function of the power of the thunderstorm that we're talking about. Okay, that concludes this video podcast. This served as a general overview of precipitation. In our final vodcast for Chapter 12, we will consider some of the different types of fog.